So let's continue. I realized that at first our word is very small, and then we started to write as more and more bigger. Okay, so let's go back to the smaller, words. So let's copy this, the eigenvalues. Okay, our eigenvalues. Just put it here, and then this is step 3, step 4. Okay, so let's continue with, maybe I just, never mind, let's continue with the big font. So step 4, which is find the eigenvector. Okay, I think you know what I mean. Okay, this is eigenvector in terms of that. So now we will need this again. Okay, so when setting this is very important. Okay, when you set wrong, everything is gonna go really terrible. So we just, never mind. I just put this thing out, and then I'll just solve for all of them. Okay, and then let's put it. So for lambda is equals to 6. Okay, so let's put 6 as lambda. For lambda is equals to 1, just put 1. And for lambda is equals to 3, so let's put 3 over here. Lambda. Okay. So therefore let's do it. So for lambda equals to 6, okay, you just do it out of the matrix. You'll get 6 minus 2, 4, minus 2, 0, minus 2, minus 1, 1, 0, 0, 0, and then 3, and then we have x, y, z is equals to 0. Okay, so this is what it is lah. Okay, let's pull this thing down so we have more space to write at the bottom. Just put it here. Okay, so once you set this, you will eventually see that, okay, 0, 0, 3, 3z, okay, 3z is equals to 0, okay, z is equals to 0, therefore z is equals to 0, okay, and then second step, since we know that z is equals to 0, and that this portion, as you can see, this portion here is, minus 2, and these two are the same. Okay, if you multiply by minus 2, you'll get 4 and minus 2. Okay, so they are the same. So in fact, this is also many solution. Lambda, many solution, and therefore we can use the relationship method again. Previously we talked about. So it will be 4x. Let's get a small number. So let's take it as minus 2x plus y is equals to 0, and y is equals to 2x. Then if y is equals to any constant c, then 2x is equals to c, right? Because y is equals to c, then 2x is equals to c. Therefore, x is equals to half c. Okay, this is a very important method. Please remember. Okay, please remember. And then now you know x and y, and you know z. Therefore, so we know that x is equals to half c, y is equals to 2 over 2c, right? And z is equals to 0. We will have, we write it as, we will have 1, 2, and 0. Okay, so are we correct? We are correct. I see the thing, and it's, yeah, correct. My answer says that. Okay, so this is how it do. How it is being done. Okay, how it do. What the? Okay, so let's continue to evaluate this. 1 minus 2 is minus 1. Sorry. Minus 1, minus 2, 0. Minus 2, minus 4, 0, 0, 0, minus 2. yeah, x, y, z is equals to 0. So from here we also see that okay, z is also 0 because minus 2z is equals to 0. Therefore z is equals to 0. Okay, 0 times x 0, 0 times y is 0, minus 2 times z is equals to 0. Therefore z is also 0. So many 0. And you also see that okay, there are many solutions also because they are the same. Okay, if you multiply, okay, they are not the same. I mean, maybe the if you multiply this times 2, you'll get this. Sorry, I've been doing it for like 4 hours, so I'm very tired. So excuses anyway. So minus x minus 2y is equals to 0. So what we're doing now is to make the relationship again. And minus x is equals to 2y. Okay. So if okay, what if we write it in this manner? Minus 2y is equals to x. It's the same thing. Okay, let's bring x over. So if x is equals to 0, no. if x is equals to c, any constant c, then then minus 2y is equals to c, right? Since minus 2y is equals to x. And then therefore y is equals to minus half c. Okay, and then since we know that okay, hold on. Oh, okay, there's a minus over here. Be careful. So apparently, what do we do over here? And then since we know, okay, hold on a while. Yeah, it should be, but I think the answer might be wrong. Anyway, so x is equals to 2 over 2c, and then y is equals to minus half c, and then z is equals to 0 since we know, and therefore we have minus 1. Sorry, no. So over here, okay, like that. So it's 2, okay, 2 minus 1 and 0, which is the answer. My answer is minus 2 and 1. Okay, it's anyway. It can also have minus 2, minus. So another method is, let's say if you take let's do it. Okay, my answer is minus 2, 1 and 0. Alternatively, although I spelled wrongly, if x is equals to, so let's say, so this is the history already. Okay, this is history already. Okay, let's use another color alternatively. Okay, alternatively, minus x minus 2y is equals to 0. And then if, let's say, x is equals to, okay, minus x is equals to 2y, and then, well, you should get the same answer. Let's try, let's try. And then if minus x is equals to c, then 2y is equals to c, right? And therefore, y is equals to half c. Okay, and since we know that z is equals to 0, and we can formulate that x is equals to minus 2 over 2c. Okay, since it's 1c, let's bring the negative over, and then y is equals to half c, and z is equals to 0. Therefore, we have minus 2, 1, and 0, which is our answer. So it's just how you do it okay. So apparently, yeah, I'm correct. Yay, luckily. So let's do the last one. I think you already know what I'm trying to convey the message. If you just don't want to watch, just close this video and do your own job. So last part, just write it down here. So we have 1 minus 2 0 minus 2 minus 2 0 0 0 0. Okay, so apparently this is a little tricky. Okay, there's two equations, yet they are not very much near each other. One key thing. Okay, hopefully you didn't off the video. Damn it. Okay, one very important concept over here. Shit. Please come back if you off the video. Okay. So if okay, if 0 z is equals to 0, then z is equals to 1. Okay. I don't know why, but it is there. It is there. Don't ask me why. Okay. So let's just take it. And then since we know that, okay, so we already solved z. Okay, we already solved z. Now this is the portion that is a little tricky. So let's take the simultaneous equation. Let's try to solve this. So let's say 1 minus maybe, and then we take row 1. Okay, row 1 minus row 2. Okay, so row 1 minus row 2 minus 1 minus minus, so we have 3, and then this will be 0 0, and we have 0 0 0. Okay, so it comes from here. Okay, so therefore we just write simultaneous equation, and therefore you will see that x is equals to 0. Therefore x is equals to 0. Okay, 3x is equals to 0, x is equals to 0. And since x is equals to 0, and if x is 0, then definitely y is also 0, right? So therefore y is equals to 0 also. So this is why the answer is x equals to 0, y is equals to 0, z is equals to 1. Therefore we have 0 0 and 1. Okay, and yeah, so just to recap everything, okay, just to give you an overall summary so that you can understand what the whole approach is that the first step, remember it's not to be complacent when you set up the equation. Okay, when you set up the equation, make sure you know remember this negative, this you have to change the sign. Okay, you have to change from positive to negative or negative to positive because you're minusing. And then you use your rules of Sores. It's a very safe method compared to the determinant method, although determinant method also is useful when you're doing other things. Yeah, whatever. So after you use the rules of Sores to have come out this equation, you use your synthetic division to come out your three eigenvalues. Then once you get your three eigenvalues already, you can start to solve your eigenvectors. And remember the eigenvectors wise, if there is many solution, make sure be careful of the y equals to c thing. Okay, make sure you sub the constants, and then this is the only thing I need to convey. And then the other thing is the last thing is the if everything is 0, and then if let's say x and y existed, but if z is 0, then should be 1, right? Z should be 1. But if z should be 1. So this is a concept that I don't know, but it is there. Okay, so yeah, goodbye.